will continue with a little bit longer talk about a very interesting topic. It's relevant and everybody's talking about it. Well, at least the people that I know in my surroundings of the AI ecosystem. It's about governance with AI. Please welcome Frauke Behrendt.
Thank you. Right, wonderful to have you all here for my presentation. So I'm going to talk about governance with AI, shaping sustainable futures and decision-making. I'm an associate professor here at the university, part of the Technology, Innovation and Society group, and my main expertise is on digital society, sustainability and AI, and mainly in the domain of mobility. And you will probably see some examples from that today. Right, let's get started with a local photo. Anyone seen some of these bicycles around Eindhoven? Yes. Anyone been brave enough to ride them? Slightly slower response here. I know this is a country where people very much like to ride their own bicycles, which is quite different to some other countries I've researched in. But what I really want to talk about is that shared bicycles, scooters, and cars are part of mobility as a service, where we don't own the vehicles. I know that's really difficult for Dutch bicycle users, but it's convenient to use them for short trips or to combine with public transport. And there's a big hope on a societal level that mobility as a service can really help to replace car trips, maybe even replace car ownership, and thereby make mobility more sustainable. But what does that have to do with AI and with decision-making about the future? So let's start thinking about data. What kind of data matters for these bikes, for mobility as a service? Most of you are experts in this, so you can probably already imagine some data, zeros and ones floating through the air, location data, battery status, fleet data about distribution and maintenance, customer data about trips, bookings, payments, other modes, other operators, how it's all kind of integrated or not. You can foresee all kinds of problems already, you experts. And where there's lots of data, of course, there's also lots of opportunity for AI. And mass projects and companies often stress how they use AI to optimize and to enable sustainable mobility. And we also saw that in the Dutch AI pilots. That was one of the main narratives. It's around sustainability, and it's around the use of cutting-edge technologies such as AI to achieve this. So this is also where our research started. We were driven to understand, I may have another slide, there we are, how exactly AI is used in mobility as a service, and how those claims around sustainable mobility are arrived at, and whether they are true or not. Before I go into a bit more detail about that research journey, I also want to flag up that we found a much bigger issue as part of the research that is to do with how humans and AI work together. And I guess that's why I'm here today, how they work together in governance, and especially in governance that is relevant to sustainability. But let me not get ahead of myself. So back to our original question. How is AI used in mobility as a service, and how does that make mobility more sustainable? This slide gives some detail about how we went about this. Some people really care about the detail of methodologies. You're very welcome to ask me some more questions about it later. For the rest, just to say, we used two bodies of literature, one rather technical on smart mobility, transport modeling, computer sciencey kind of literature, and a second body of literature, social science literature on data governance, algorithmic governance, and responsible innovation. We also conducted quite a few participant observations at 10 workshops in the Netherlands and abroad, where people, different kinds of stakeholders, talked about the technical capabilities of mobility as a service. Now, I keep talking about we, so who's that? Most of the research was actually carried out by a brilliant young researcher, Eriquette Servoux, who I had the pleasure of hosting as a postdoc for a couple of years here at the university, who now works as a consultant. So lots of other people get to work with her too. So what did we find from analyzing all that literature and listening to all those people talk at the workshops? We found that AI is relevant for three key elements of mobility as a service: end user demand, mobility service supply, and mobility system integration. And we look into each of those in a little bit in detail. I'm also really old school, so I like holding on to paper, and it was interesting to hear about embodied knowledge earlier. It really makes me feel so much better to hold on to paper. Here we are with old school professors. So the assumption with end-user demand and the use of AI in this element of mobility as a service is that by understanding users' travel behavior with data-trained AI algorithms, platforms can create convenient and flexible mobility packages, and thus offering a competitive alternative to the car, which in turn will make them act more sustainably. So this is really about understanding the user behavior, about personalizing the journey planning, integrating ticketing and booking, and creating these kinds of flexible and attractive packages. It's also about nudging, eventually, the user behavior to travel in climate-friendly and efficient ways. Now, we also identified some critical issues. One of them is that this kind of ignores rebound effects. So, for example, people might use mobility as a service as an add-on to their private car use. Or people might use car sharing and ride-hailing at the expense of active modes such as cycling. Also, algorithms might contain user-related biases dependent on two factors. First, the specific values the algorithm developers insert into the algorithms, which might include biases on price discrimination of mobility services based on location and income. So we've seen some research on Uber where certain kind of locations had to pay more because they were perceived as more dangerous. So this was kind of based on user location and income. And there's also been some research, for example, on discrimination against people of color because the system assumes there's a higher risk of potential crime. And that also relates to some of the face recognition issues we saw earlier in terms of people with dark skin. Data collection and processing might also include inadequate data sets. So this kind of is a similar issue. So picture yourself, someone who might use the fancy bicycles we saw earlier or any other kind of mobility as a service. So you've got a certain kind of people in mind, and you may also want to picture people who are really quite unlikely to use any of those new services on their smartphones, do all the kind of fancy digital stuff, and engage with these new forms of mobility. Well, you can already see how the data sets that are used to train the AI used in mobility as a service are being fed in quite different ways, which means that, of course, the services will be very much tailored to the kinds of people that have already used them and not be so useful to the people who haven't really contributed to the data sets. Now, let's go to the second element. This is the service supply. And this is really thinking about how to get all the vehicles into the right place and what vehicles and all the rest of it. So AI recommenders are used to integrate data from several mobility service and providers. This is also why it's so complicated. Just as my stack of paper. So this is really using AI to learn about the transport mode availability and supply, about redistribution of vehicles, but it also requires collaboration amongst several stakeholders and members, and therefore new governance models, which I'll come back to later. Just one concern I want to highlight, because we don't have all that much time today, is that one element related to sustainability is also really the high energy consumption of AI in these processes, and that is not typically included when we think about how sustainable these modes are and any of the life cycle analysis. And for the third part of this, this is the mobility system optimization. So this is really about bringing together the demand side, the user perspective, and the supply side of the vehicles. So this is kind of the matching of demand and supply. So this is kind of large-scale optimization models that sort of try to model the total supply of vehicles ahead of time based on the kind of aggregate demand that there is per day. And there are also kind of more operational AI elements where the data algorithm really determine which users are assigned to which mobility mode, depending on the more short-term availability of supply. And as part of these processes, and we already heard earlier from someone from the province, A lot of these AI systems are also kind of contributing to kind of becoming the brain of urban mobility, to integrate a lot of data sets that are not only about these shared modes, but also from the city and from public transport, etc. So it's really kind of becoming the brain of urban mobility and also becoming part of a real-time algorithmic governance. And this governance element is really something I'd like to focus a little bit more on for the remainder of this talk. But before I do so, just a super quick recap. What we did up to now, we talked about the user side, where the training data sets can be quite biased towards typical users. The supply side, where people might be nudged to use an Uber rather than cycle. And the mobility system optimization, where making a profit for all of these mobility as a service startup is at least as important to making decisions on how sustainable all of this is. So, therefore, it's really important to get our teeth into this governance issue. We'll start with the question, how are decisions around mobility taken? And this is not the kind of poldering thing I'm talking here about. I'm learning how Dutch decision-making works, and I think Brabant decision-making in particular as well. But in any case, we have multiple actors involved. We have policymakers and companies mainly in the case of mobility as a service, but also civil society organizations. And they create frameworks, they discuss, they take decisions, shape those decisions over time. They are part of a governance process. And they do that in advance usually to set out a framework that will then guide sustainable mobility, for example, mobility as a service. Hence, I put a little arrow down there. So the question is now, what happens if AI becomes part of this governance process? Algorithms make predictions, suggestions, and decisions, but those usually happen in real time. So they adapt to user choices and availability of vehicles, and rather than directly governing mobility with decisions at particular moments in time by humans, the decisions are mediated by these AI algorithms. And of course, we've seen this for a long time. People have used software, algorithms, AI for quite a while. But we increasingly see really a tendency to outsource decision-making by authorities to AI-based algorithmic governance. And we also talked earlier already about the societal implications of the human-AI integration, and I think this is one of those examples where that's really important. And especially those decisions where our limited thinking in terms of fast and slow thinking, etc., makes it really difficult for us to often take these complex decisions, for example, in the light of climate change. Now, this hybrid decision-making, that's what we call this kind of AI inclusion in the governance process. And we really want to highlight with this term hybrid governance that it takes both humans and AI to do this. So it highlights on one hand the role of AI as actor, not just a techie thing, but also the interplay between human actors and AI algorithms and how that creates new accountabilities, opportunities, but also risks for sustainability. And the performativity and real-time dimension requires co-creation and collaboration between developers, policymakers, citizens, and algorithms to really efficiently respond to these sustainability challenges. At the same time, it's really crucial that these objectives and values are decided collectively by human, private, and public actors to ensure alignment of interests and public value. I mentioned earlier that a lot of these mobility as a service platforms are at very early stages, so they're really struggling to survive financially. And therefore, a lot of the optimization algorithms are not necessarily optimized to make things more sustainable. But it is assumed that mobility as a service will make our society more sustainable. So the people who are involved in taking the decisions of what is optimized for are becoming really central here. And they often tend to be developers as well. And even if the algorithmic codes are published for policymakers and citizens, when these rules and regulations are expressed in code, only a small fraction of people, mainly computer scientists really, are able to understand them. And this lack of information and explainability for policymakers and for citizens kind of decreases their role and power in decision-making around how to move in a city, what we're going to do about climate change. So the power kind of goes more towards the algorithms and less with the people. Also something we've heard quite a lot about today. Now, to avoid this kind of what is called algocracy, where the algorithms are the power-making part of society, it's really crucial that policymakers and users gain capacity to make sense of the complexity and capabilities of AI, but also know how to co-create the objectives and values for designing these platforms. Now, it's time to wrap up. So, let's ask ourselves, what are the implications of hybrid governance for public value and for sustainable mobility? Our results show that a balanced hybrid governance approach between humans and algorithms with explicit and dynamic feedback mechanisms is required, so that public and sustainability goals are ensured. We need transparent and democratic deliberation of mobility as a service objectives. And to ensure public value, these objectives needs to be tailored to local sustainability priorities. So there's not a one-size-fits-it-all approach here. And they need to manage the algorithmic biases we talked about earlier. And most academic debates on AI and sustainability really focus on one thing or the other. They talk about how AI can be used to make things more sustainable, make things more efficient, etc. AI is going to save the planet, all of those kinds of debates. Or we talk about the sustainability of AI, so how power-hungry the data centers are, etc. And what we are hoping to add to the debate with our hybrid governance is to really think about sustainability with AI. And in conclusion, I want to open up a debate that we may be able to have here, may have to continue over lunch, because I'm also acutely aware I'm one of the two people standing between you and lunch. I have some questions for you around hybrid governance with AI, humans, and governing together. Questions about shaping our sustainable futures and decision-making. How to best care for sustainability in hybrid governance processes. How to translate policy goals such as emission reduction or accessibility into design goals of AI functionalities. How to co-create strategies for hybrid governance that allow for open trade-offs between individual, market, and public interests, especially in the light of the climate crisis. And who should be involved in all of this? Developers, policymakers, company leaders, civil society. And what do their AI skills look like? I leave it here. Thank you.
Thank you very much, Frauke. Well, I think it's a very interesting story, absolutely. And what I like very much is that you end with questions. So instead of asking,
make your job easy, huh?
Yeah. Instead of asking to the audience, are there any questions? Can we have the questions back on the screen, please? I would like to ask to the audience. Does anybody want to answer one of these questions? Not with a full talk, of course, just a short answer. Is there anybody that has anything to... Yes, here, somebody on this side.
All right, good afternoon. I would like to tap on the bottom one and also talk a little bit about what I'm currently working on in response to that. So I'm part of a consortium that I am leading, best that I can, first time, which is called Deliberation at Scale. And we are trying to use AI models to make it easier for people to go into conversation together and figure out what it is that we care about. And this is kind of the process that we are working on. We built the software and the tool in the last 3 months. We did our first tests with 500 people, but this is exactly also the question that I want to get better answers in. So perhaps it could be part of an answer that you're looking for.
Well, wonderful. That also gives me the opportunity to plug that we have an innovation master at the university with wonderful graduates who create new things after they go out in the world and network and come up with new answers to our questions.
Okay, thank you. Room for one more question or answer. There, behind, I see. Oh, that's risky.
High risk. Just
High
be
risk,
aware of.
yes.
Okay, so since you talked about algorithmic governance, I was wondering what are your thoughts about using blockchain technology for governance? So, for example, decentralized autonomous organizations.
Yeah, good question. Actually, in some of my other work, I've also looked in the use of blockchain technologies related to cycling projects. For example, how it can be used for smart contracts between citizens and governments to encourage people to cycle and basically pay them to cycle, which had mixed results, I would say. But I think whichever technology we use, it really matters on how it is designed and which goals we have in mind when we do so, and to kind of continuously monitor that that is really happening, whether it's AI or blockchain or any other kind of smart something or other. I think they're all exciting, but I do think they all require humans in the loop at some point.
Okay. Thank you very much, Frauke.
Thanks.
Thank you.